Hi friend, welcome to my channel Digital Remote Sensing. Today I will discuss how to estimation of surface runoff using SCS curve method, number method by remote sensing and GIS. Study area of this Shobha Nodi watershed, Purulia, West Bengal. So at first open this methodology of the study area. So parameter of this estimation of the surface runoff using SCS curve number method. So at first topocity, satellite image and soil map. So generate it to boundary and drainage network map at first. Then satellite image, land use, land cover classification image, and then study area soil map. So three parameter, there is this cliff and land use land cover map, soil map and soil infiltration map to hydrological soil group map. So three parameter there are mask by extract or intersect. Next parameter there are rainfall. So rainfall and AMC condition means incident moisture condition, and there are next process a step the curve number and calculate runoff from each grid particular VQ runoff volume. So this is method of the estimation of runoff of the surface. So at first open this ArcGIS software, then open the topocity map. So open the topocity map for particular portion. So this is the topocity map of this study area. So stress type, that is the ESRI, and apply and OK. Clear this image. So this is this Shobha watershed or Nodi of this portion. So at first delineated this boundary of this particular portion or watershed. So at first create a shapefile of this delineated this portion of this topocity. Full runoff and right click new and personal database. Right click new to feature class. So name of this watershed and type of features polygon, and next WGS projected coordination WGS 1984 UTM zone 45 north, and next and filled and finish. So next step, there editing and start editing. Polygon and delineate this Shobha watershed or Shobha Nodi. This is two drainage. So this is this watershed of the Shobha Nodi. So this is this boundary of the Shobha Nodi. Next, there is this divided and micro sub watershed. So at first, so delineated this boundary. So there are copy of the shape file another portion. So at first remove here and go to portion. So micro watershed final boundary. So this is this portion and copy and paste and open this copy micro watershed boundary. and go to open attribute table at field. So micro water set text and OK. So select this portion and start editing. Divided this portion another micro water set. So there are cut polygon. There is this micro set 1. Select this portion and name this micro set water set A. And next the micro water set 2. There is the next water set of this portion. Rename this B. Water set. There are A and B. The same method used. Delineated this macro water set of this whole water set. So there is divided macro water set of this portion. So there are micro water set name A, B, and another micro water set divided of this portion. So there are opposite collected water set and micro water set. Next step, there are soil map create. So image this portion, and next there are open of the soil map. So there are soil map of this study area. So at first open this copy of this file at first, delete this whole micro water set boundary. So there is the micro water set of this image. The next step, that is cutting of this portion of the soil group. So there are available variety of soil group. So at first Go to open attribute table and add field. Same macro water set. Soil group. Next, the add field, soil group, one, text, and OK. So at first, editing and start editing the macro water set, soil group. At first, select results. So there are macro water set C, but there are two soil group W092 and W091. So at first, so there are W092 soil group. So unselect this portion and then select portion, rename, so W092, and next this portion automatically another W091 soil group. So there are this way of this cut of this soil group W094 and W104. So complete. So this portion of this W092 hydrological soil group. So hydrological soil group, there are four groups. Group A, B, C, and D. So characteristics of hydrological soil group A, sandy and silt, sandy clay, and clay loam. These characteristics of this portion. So W092, there are characteristics. So group C. So index of these characteristics of this group. So W092. So characteristics. So there are sandy, clay loam, hydrological soil group. This process done whole work. So complete this soil map create. So group A and group B portion and group C micro water set E. So next step, there are list 3 image classification for address, land use, land cover, map create. So open address imaging 9.2 and open the satellite image for list 3. Raster and band combination. and there are image classification techniques used. Image classification of this, there are image classification. So raster, so there are water body, cultivated land, dense forest, open forest, agriculture fallow, dry fallow, and settlement. So there are image classification techniques used. Image classification, this satellite image. So open this classification image, and next step, there are boundary of this watershed. Shape file open. So this portion extract by mask. And okay. Remove this whole classification image. So there are extract by mask of this portion. Next step, there are open of the soil shape file. So there are soil map. Next step, soil group through extract by mask particular soil group through. So at first select this portion and extract by mask. So soil group image input and okay. This portion there are extract. So this method whole classification image extract. So next there is this portion. Two portion there are extract. This method use whole image extract by mask. So there are whole portion by extract already complete, and next step go to sub watershed wise attribute table to copy of this area. So at first sub watershed 3 sub watershed. So there is the sub watershed divided 3 part, sub watershed A, and so this is the sub watershed A, but different hydrological soil group. So hydrological soil group wise copy of the attribute table. So at first right click of these classes. So go to open attribute table. So there are available attribute table and area. So copy of this table. So at first go to soil group wise label of this classification image. Labels and soil group. So soil group A, and C, there is the micro water set A. So at first copy of this micro water set A, attribute table. So shift copy selected attribute table and go to paste Excel sheet. Already copy of this class name, not area. So particular portion there are copy. So actually this work already done. So this class name on area there are copy and paste here. So this way already copy whole water set of this soil group micro water set. So there are micro water set A, but 3 soil hydrological soil group. So proper complete of this work, same method, shift copy selected file. So this method use copy whole water set or micro water set soil group hydrological soil group and paste Excel sheet. So settlement there are next step there are calculation of the curve number. So actually this curve number hydrological soil group wise. So read this PDF. So curve number there are hydrological soil group. So this is the Wikipedia of this runoff curve number. So there is a soil group A, B, and C and D. So full developed urban area vegetation established curve number. So open space Fairyland. So Fairyland curve number group B 85. So agriculture fellow there are 85. So this method use full curve number extract by and write down this curve number full sub micro water set subset A, B, and C whole water set. Next step there are area. So area into this area into Cn divided by total area. This is area and whole hydrological soil group area and divided total area. And calculation of the sum of this area into curve number divided total area. So this method used to sub watershed A, 3 soil group: hydrological soil group B, hydrological soil group A, and hydrological soil group C. So there are total watershed area. So sum of this B8. So this is the B8 and B19 and B29. Sum of this hydrological soil group B total area, hydrological soil group A total area, and hydrological soil group C total area of this subwatershed A 3 soil group, this micro watershed under. So ultimate curve number. So there are ultimate curve number D8 into area into curve number divided by total area into B8 total area divided by total watershed area I14 and plus same way D18 into B19 area total area divided by total watershed area plus and plus D29. So D29 into B29 divided by total watershed area. So there are ultimate curve number. So approx curve number there are 51. So this process use total curve number and ultimate curve number calculation. Next, there are subwatershed B. Same method use copy of this watershed hydrological soil group A classes and area and curve number already here available. Runoff estimation Wikipedia and area into curve number divided by total area. Same way use 3 hydrological soil group calculation and list total watershed and ultimate curve number and approx curve number. So subwatershed D, subwatershed E and total watershed area and subwatershed F hydrological soil group A and C total watershed area and ultimate curve number and approx CN number curve number 48 and at least subwatershed G hydrological soil group C and total watershed and ultimate curve number and approx curve number. So copy of this total watershed copy of this total watershed and ultimate curve number and paste another copy of this portion. So already copy whole watershed total area and ultimate curve number. So next step, there are calculation of this rainfall and VQ, volume of runoff, surface runoff estimation, final works. So copy of the same portion, sub watershed A, total area watershed and ultimate curve number. So ultimate curve number 51. So meteorology, the rainfall data. Meteorology use. So rainfall data is very important tool or parameter of the runoff estimation calculation. So day 4th January to 18th November, and maximum temperature, minimum temperature, relative humidity and rainfall nanometer or millimeter. So copy of the same data and paste here day, maximum temperature, minimum temperature, relative humidity and rainfall, and calculation of this rainfall. So actually calculation means total rainfall in previous 5 days. So 4th January not available of this rainfall, so there are 0. And next, so 9th January and previous 5 day rainfalls 8, 7, 6, 5, 4 and 3. This rainfall and summation, so there are previous 5 day 20, 65, 19, 34 and 30, summation 168. So this method use the calculation of this previous 5 day rainfall. And next step, there are, so there is the MIMI, millimeter calculation, and next AMC means incident moisture condition. So AMC means how much rainfall of this area particular. So MC1, MC2 and MC3. So wet season and dry season. Less than 0.6 inch rainfall. So there are this portion, there are MC1 and 4.6 nanometer or millimeter. So there are nearly standard soil, and due to heavy rainfall previous 5 day highest runoff potential. So MC3, so this method use calculation of the AMC. And next, their conditional curve number. So there are another curve number Cn and constant is 0.2s. Curve number for 2 and curve number 1 and 2. So actually at first MC curve number 51, MC1. So curve number 51. So find this curve number 51. So curve number 51, there are curve number AMC 1 So AMC 131 and write down this 31, and next tab number 51 AMC3 write down this 70, and AMC2, so already AMC2 means 51, write down of this Excel sheet 51. This process use calculation of this AMC and conditional curve number. So there are conditional curve number of this portion. Next there are S. This formula use calculation of this portion, and next 0.2 into S means there are S into 0.2, and next the VQ, volume of runoff. Actually this equation use of this calculation of VQ. So Q means runoff and P means precipitation or rainfall. S means is the potential maximum soil moisture retention after runoff begins. So inertial abstraction and 0.2s, this equation are used calculation of this VQ. So G4 means this rainfall minus 0.3 or 2 calculation. 0.2s means into K4 s root over to the power 2 and divided by G4 plus 0.7 into K4. This equation used of the calculation of the VQ. This equation. Same method calculation. Whole 7 micro water set A, B, and approx curve number at day, maximum temperature, minimum temperature, relative humidity and rainfall. Same way calculation and AMC and conditional curve number and S and 0.2s and VQ and summation of this VQ. So same way calculation of this 8 micro water set VQ. Now calculate this complete for the VQ surface runoff volume. So add this file or Excel sheet ArcGIS. So at first open at micro water set boundary. So this shape file at Excel sheet. So check this attribute table. Do not add of this Excel sheet. Right click of the shape file and then join so at this Excel sheet VQ file and OK. So check this attribute table, automatically add of this VQ, and next work there a group with map of this VQ surface runoff calculation. Go to layer properties, symbology and quantities, and F2 automatically create normalize VQ. So change these classes. I am choose 5 classes or 3 classes and apply and OK. So automatically VQ calculation runoff estimation. So deep blue, there are high surface of runoff and but less or low blue color, the low surface runoff potential zone. So there are various way of this VQ calculation. So this work already done. If my video is helpful to you, please like this video. It will be very helpful every ArcGIS learner. So share this video and subscribe my channel. Thanks for watching.